So with lesson 22, we're going to look at limits at infinity. Let's just jump into some problems to try and explain this. So let's say that we're trying to find the limit as x approaches infinity of 7 plus 10 over x. So as x is increasing, we know this value is decreasing or getting closer to 0. But then we have this 7. So we know the limit here is 7. Let's find the limit as x approaches negative infinity of 13 over x minus x over 18. So as x is decreasing here, this is going to be approaching 0, right? And then as x is decreasing here, we're going to be approaching negative infinity. So this limit is going to be negative infinity. Now you probably won't see those on the exam. You'll probably see a rational, or it'll ask for the limit of a rational function, which might look something like this. The limit as x approaches infinity, 7x plus 7 over 19x squared plus 13. Okay, so we use the general rule here, which means you take the leading coefficient. You examine those because they're the determinants of what really happens here. So if you look at this one, as x is increasing, it's going to increase faster on the bottom. Therefore, it's going to approach 0. So the limit here is 0. Now the limit as x approaches negative infinity of the same function. Again, we're going to examine this with the general rule. So as x is decreasing, it's going to decrease faster down here, but it's still going to be positive, right? So it's still 0. Try a few more problems. The limit as x approaches infinity of 4x squared plus 2 over 15x squared plus 14. So here we're evaluating 4x squared over 15x squared. So when you have the exponents of the leading coefficients, when they're the same, you're just going to look at the values out front. So here we have 4 over 15. This is going to be our limit, and it'll be the same if you were trying to find as x approaches negative infinity. It's still going to be 4 over 15. So let's find the limit as x approaches infinity of 10x to the third plus 10 over 19x squared plus 10. We just look at the leading coefficients, which are 10x to the third over 19x squared. So as x is increasing, it's going to increase faster on top, which would mean this is getting bigger and bigger. So the limit here is going to be infinity. And let's find it as x approaches negative infinity. We examine the leading coefficients again. So this is going to be decreasing. This is going to be increasing. We have negative infinity. You might also be asked to find vertical, horizontal, and slant asymptotes. So to find the vertical asymptotes, you simply find where the denominator is equal to 0. To find the horizontal asymptotes, you would, if it has one, it either has a horizontal or a slant. It cannot have both. It may not have either. But to find a horizontal asymptote, you examine the function as x approaches negative infinity and infinity. And to find a slant asymptote, the exponent of the numerator has to be 1 higher than the exponent of the denominator, or else it will not have a slant asymptote. but to find the slant asymptote, you simply do long division. I'm going to demonstrate how to find the slant asymptote of this equation. F of x equals negative 3x to the third plus 8x squared with 21x plus 40 over x squared plus 5. So you do long division. And you'll find it. This is what it divides out to. So this is going to be the slant asymptote. Y equals negative 3x plus 8.